Okay, hello and good morning. Get started on page 453, 1 to 33 all. Make sure you copy problems, show work, and check answers. Let's move on to geometry. Okay, on your test Wednesday, if you need a paper copy, make sure you see me and I'll print you one up. Let's take a look here. We want to extract perfect roots. So you're going to take that 60 and break it up. So that's going to be 2 times 30, 2 times 15, 3 times 5. And you need 2 of a kind. So 2 and 2 makes 4. These you don't have any 2 of a kind. So you're going to go ahead and rewrite that. So it's going to be 3 on the outside. 2 times 2 is 4, and then 3 times 5 is 15. The square root of 4 is 2, and then you multiply these. Do not add them, okay? 3 times 2 is 6, so it's going to be 6. Square root of 15 is number 1. All right, let's look at the next one. 120, you got to break that up. So it's going to be 2 times 60, 2 times 30, 3 times 10, and 2 times 5. You're looking for 2 of a kind to make a pair. Here's 2 2s, and then you don't have any more pairs. You don't have another 3, you don't have another 2, and you don't have another 5. So you're going to end up with is 2 times 2 is 4, 3 times 2 is 6, times 5 is 30. All right, so this adds up to 120 when you multiply. So the square root of 4 is 2, so your answer is going to be 2 square root of 30. Make sure you know how to extract roots, and make sure you know how to use your calculator. Let's just do it with the calculator also. So right now press 30, shift, square root, or however you do it on your calculator, times 2, and you should get 10.95. And if you round that, you're going to end up with 11.0. Okay, make sure you understand that. All right, let's go on. This next one right here is a special triangle. Okay, so we want you to do it with trig and using special triangles. So let's take a look at that. Let's do the trig first. Okay, so write down so, ka, toa, and you got to memorize that. We're standing here, so this is your hypotenuse across from the 90. This is your opposite, and this is your adjacent. So some kids say, well, how do you know which one to use? Well, I'm going to show you. Okay, if we're shooting for the x, we need to use an a. So here's an a, and here's an a. But we're not going to use the y because that's 2 variables. We're going to use the 4, which is an o. So it has to be something with an a and an o. An a and an o is tangent, and that's how you figure out what you need. So you're going to say the tangent of 60 degrees, and then the a is on the bottom. The one that's at the end is always on the bottom. So the a here is the x. So put an x here and put a 4 here, so it's opposite on top of the adjacent. Now, put a 1 under here. You don't want the x on the bottom, so you're going to move the x up here, but then you're going to take all of this and move it down below. Okay, it's that little trick move that I showed you. So you're going to get x equals 4 divided by the tangent of 60. Okay, make sure you move all of it down. So clear your calculator. We're going to press 4 divided by 60 tan. Make sure you press equals right here. Okay, press equals, and you get 2.3. So x is equal to 2.3. And that makes sense because this is 4. This is your short leg, 2.3. Now let's go after the h, or the y rather. Okay, so I'm going to use a different color. So if I want the y, that's a h. Okay, and then I don't want to use the x even though I know it, but I rounded it. So I want to go here to the 4. So I want something with an h and an o. So look at your trig functions. This is how you figure out what you need. An h and an o is this one. That's your sine. So put the sine of 60 degrees is equal to, the h is on the bottom. So here's my h, which is y, and then the 4 is on the top. Okay, remember the last one goes on the bottom. Again, you want to switch these. all of it, okay, all of that. So you're going to get y equals 4 divided by the sine of 60, okay? So let's take a look at this. Now, on your calculator, you're going to clear it out, and you're going to press 4 divided by 60, and then press sine, and press equals. Make sure you press equals. I get 4.6, and that makes sense because that's your hypotenuse, and that's bigger than this one, and it's bigger than that one. Okay, so remember these answers, because now we're going to do special triangles. Okay, watch how I do special triangles. Okay, now, let me move this page for a moment, and we're going to redraw this triangle because I wrote all over it. Okay, so here we go with special triangles. So let's redraw this. So this is 60. This is x, y, and 4. Put circles. Okay, make this a 30, 60, 90 triangle. You had to memorize 1, 2, and the square root of 3. Make sure you know that. This is your big one. So across from the 90, we'll always go the hypotenuse, which is the big one. The 30 will always get the 1, and this one will get the square root of 3. Okay, now we're ready. You're going to put 2 over y. Remember, put the bubbles at the top, 1 over x, and put your bubbles at the top, square root of 3 over 4. Now, this one, you know both of these, so that's your scale factor. So you're going to use that twice. So square root of 3 over 4 once, and then square root of 3 over 4 twice. You want to put 2 over y for one of them and 1 over x for the other one, okay? So again, we're doing this 2 different ways. So you're going to get y times the square root of 3 is equal to 8. 4 times 2. You're going to divide by the square root of 3. So you're going to get y equals 8 over the square root of 3. Now, we'll use the calculator in a minute. This one, you're going to get x times the square root of 3 equals 4, and then you're going to divide by the square root of 3. And when you divide by the square root of 3, you get x equals 4 over the square root of 3. Now, let me show you something. Watch. Clear your calculator. Press 8 divided by 3 shift square root, press equals. I get 4.6. Okay, look at what we had before. 4.6. So we got the same thing. Okay, watch again. Next one is going to be 4 divided by 3 shift square root equals 2.3. And look at the answers from before. 4.6 and 2.3. So make sure you can do it both ways. Now, before I give you your practice test, let me show you a little algebra that you need to know. Okay, so watch. There's something called rationalizing your denominator. So write this down. Rationalize the denominator. Okay, so one of them was 8 square root of 3, and one of them was 4 square root of 3. Copy that down. Okay, now on the EOC, you got to know this, so look up here. To rationalize your denominator just means to write whatever your denominator is twice. You cannot have a radical in the denominator, so write that. No radical. See that sign right there? That's called a radical. No radical in the denominator. Okay, so write that down so you know. Now, the way you can do it, of course, you can use a calculator, but you got to know how to do the math here. So you're going to write that twice. So put the square root of 3 and square root of 3. Watch what happens. You're going to get 8 square root of 3. You can have it in the top. 3 times 3 is 9, but the square root of 9 is 3. So your final answer is going to be 8 square root of 3 over 3. Okay? That's your answer. And that's how you rationalize your denominator. Watch again. You're going to go ahead and get rid of this because you can't have a radical. So it's going to be the square root of 3 twice, top and bottom, which really equals 1. And that's why you can multiply, because if you multiply by 1, it doesn't change anything. All right, so you're going to get 4 square root of 3 at the top, and then 3 times 3, you're going to get the square root of 9, just like we did before. So it's going to be 4 square root of 3 The square root of 9 is 3. Now, you cannot reduce these because one's on the inside and one's on the outside. That's your answer. And that's how you rationalize your denominator. Let you try one more. Put down 2 square root of 5 and make it a fraction. So put 7 over 2 square root of 5. All right, let's rationalize. Now look, you only want to get rid of this. So you only want to write that twice. So put square root of 5 twice. So you're going to get 7 square root of 5 over 2 square root of 25. And so you're going to get 7 square root of 5 over. The square root of 25 is 5 times 2 is 10. That's your answer. That's how you rationalize your denominator. All right, let's get off of this a minute. Let's take a look at your practice test. For those of you at home and can't be with us, here it is. And I will upload it to Canvas. But you can always come back to the video, okay, if you can't seem to locate Canvas. And this is your practice test, okay? And there are the answers. Now, I'm going to put some review questions on here. And let's see if we can start going over this thing here. All right. It says find the value of A and B. Let me get this out of the way. All right, so let's see what we have here on this one right here. State whether the triangles are similar. Well, look here. There's 3 ways to prove similar. Similar triangles. There's 3 ways. There's one that's called angle-angle similarity. Number 2 is angle-angle similarity. And number 3 is side-angle-side similarity. Copy that down. These 2 triangles are not equal, but they're similar. You see how this angle is equal to that angle? Now we got to see if the corresponding sides, we're going to take the smaller one over the smaller one. So 16 over 8. We want to see if that's equal to 64 over 32. Now this is going to be 2 and this is going to be 2, so the answer is going to be yes. They are similar by side, angle, side similarity. Make sure you know that. All right, the next one. This one we're going to do the track method. Now you were taught this, so it's going to be 16 over A equals A over 4. Okay, so you're going to cross multiply. I think that's 64. That gives you A squared. So now you get rid of that by doing the square root. So the square root of 64 is 8. And so A is equal to 8. Now look at this little triangle here. This little triangle now, we have the 8 right here. And we have a 4, and we're looking for B. To get B, you're going to put your legs together. Remember, the legs go together and the hypotenuse. So it's going to be 8 squared plus 4 squared is equal to the hypotenuse squared. So this is going to be 64 plus 16 equals B squared. So B is going to be the square root of 100. No, that's square root of 80. Okay, so the square root of 80, we're just going to use a calculator on this. Okay, so press 80. We could extract, but we're not going to. Press equals. I get 8.9. Make sure you get 8.9. Again, you're doing the track method, and then you're doing Pythagorean's theorem. All right, let's go on. This one right here is also the track method, so I'm not going to work it, but I'll set it up. So UV is 4. That's this one, UV. And then UT is 6.25. And you're looking for this. What's the value of UW? UW is this one. Sometimes they ask for these, so then you'd have to do Pythagorean. So the track method would be 6.25 over x equals x over 4. This is called your geometric mean. Make sure you know that. Geo mean. It's an average. All right, so you're going to cross multiply and then take the square root. Okay, so x squared is equal to 6.25 times 4. You're going to multiply and then hit the square root key. Number 4 is Pythagorean's theorem. You're doing side squared plus side squared equals the hypotenuse squared. So x is going to be the square root of 36 plus 64, which is 100. So that square root is 10. Okay, this one right here, you're going to do Pythagorean's theorem. You can't do trig because you don't know these 2 angles here. or one of the two angles. So you're going to put your legs together. Okay, remember the hypotenuse is alone or by itself. So it's going to be x squared plus 15 squared is equal to 17 squared. And what you're going to do now is subtract 15 squared. So x squared equals 17 squared minus 15 squared. And x is going to be the square root of whatever that is. Okay? All right, let's go on. That's number 5. Number 6. Number 6 wants you to find the perimeter. Remember, perimeter is you add up all your sides, okay? Well, here, and I'm going to show you how to do this, okay? This side right here is only 1 square. This side is 1, 2, 3, 4, 5. It looks like 5 squares. Now, from here to here, you got to do the distance formula. And then from here to here, you got to do the distance formula. So you're going to be doing the distance formula twice. This is kind of like a review here. So let's write it twice, okay? All right, so this point is over 0 up 1, 0, and 1. This point is over 1, 0, 1, 2, 3, 4, 5, 6, 7. Looks like over 7, up 1, 0, 1, 2, 3, 4. 7 and 4 is that point. This point looks like 0, 1, 2, 3, 4. It looks like 4 and 0. Okay? So you're going to do the distance formula for these two. So it's going to be 7 minus 0 here, or 7 minus 0 here, rather. And then this one is going to be 4 minus 1. So this is going to be 7 squared plus, this is going to be 3 squared. 7 times 7 is 49. 3 times 3 is 9. So we're going to get the calculator here, and we're going to take 49 plus 9, press equals, and then hit shift, and then square root. That's 7.6. Okay, and I'm rounding it off. This one right here, to find the distance, this point is 0, 0. So you're going to go 4 minus 0. And then 0 minus 0. 0 minus 0 you can just get rid of. This is essentially 4 squared because you don't need that 0. So 4 squared is 16 and the square root of 16 is 4. So you want to add up the 1, the 5, watch, 1 plus 5 plus 7.6 plus 4. And when you do, you get 11.6. And that's rounded off 11.6 for perimeter. Remember, perimeter is the distance around the object. So this one is 1. This one is 1, 2, 3, 4. And it's actually 4. So it's 1, 2, 3, 4. This one should have been 4. Okay. So we got to take 1 off of this and make it 10.6. Okay. And then you got to do the distance formula from here to here and the distance from there to there. All right, let's keep moving. Number 8. Now watch how I do this one, okay? You want the hypotenuse, which is this one. Okay, this is a 45, 45, 90 triangle. So you could use special triangles or you could use trig. So you're going to stand here. This is opposite. This is the hypotenuse. That's going to be the sine of 45 degrees is equal to the opposite, which is 3 square root of 2 over x. Okay, you want to switch these two, all of this down there. So x is equal to 3 square root of 2 over the sine of 45. Let's try that on the calculator. Watch. I'm going to work backwards on mine. So 3 shift square root times 3, press equals, divided by 45 sine. Make sure you press equals. I get 6. So the answer should be 6. You can check it on the back. Let's keep moving. Number 9. Number 9 is also trig or special triangle. So it's opposite over hypotenuse. So it's going to be the sine of 45 is equal to the opposite over the hypotenuse. This one you just multiply by 5 and you're done. Okay, I'm not going to do that one on the calculator. You can do that one. This one right here, let me think. You're standing here. You want to find x and y, so you got to do trig. So this would be the opposite. This would be the hypotenuse. This would be the adjacent. Make sure you label it correctly. So if you're going after the x, you're looking for the hypotenuse, and you want to use opposite because you know that number. So HO is going to be the sine of 45 degrees is equal to opposite, which is 8, over the hypotenuse, which is x. So you're going to switch these two. So x is equal to 8 divided by the sine of 45. Use your calculator on that one. To get y, you want to use adjacent and opposite. Adjacent, an A and an O, I think that's tangent. So you're going to say the tangent of 45 degrees equals opposite over adjacent. And the adjacent is y, and then you're going to switch these two. So y is equal to 8 divided by the tangent of 45 degrees. Make sure you understand that. And again, some kids say, how do you know which one to use? Well, if you're going after the y, you want an A. The 8 has an O, so that's got to be TOA, T-O-A, opposite and adjacent. That's the function you use. All right, let's keep moving. Let's think about this one here. How do you find y? Okay, to find y, actually there's a number 11, so let's try this one. Find the length d in simplest radical form of a cube. A cube basically has a square, and it's saying that the sides are s's. So put s's all around here. And they want to know the diagonal. Okay, so what you want to do is Pythagorean's theorem to get this diagonal here. Okay, you can forget about this piece. So it's going to be s squared plus s squared is equal to the hypotenuse squared. So this is going to be 2s squared is equal to the hypotenuse squared. So y is going to be the square root of 2s squared. Now look, here the s squared is a perfect one because you got two s's. So the square root of s squared is really s. The square root of s squared is really s. So you're going to end up with the square root of 2 times s. And that should be your answer. You might want to rework this one a few times until you understand it. All right, let's go to number 12. Find the value of x and y. Let me think about this. Okay. To get y, you want to first figure out a and b. So you got to break this up. So you got a triangle here, which is 45. We're going to call this a, call this x. Okay. And then you got another triangle over here, which I'm separating the two. We're going to call this one b, and this is 30 degrees. And this is 34. All right, so let me think here. All right, we want to also put a z here. We're going to have to find this z right here. Okay, because if we find the z, we can do trig on this to get a. And a plus b is equal to y. Okay, this one's a little bit of work here. So you might want to put a star by this one. So maybe save it for last. All right, so let me figure out z first. So if I'm standing here, this is opposite, this is the hypotenuse, and this is adjacent. Okay, so 30, opposite over hypotenuse. Opposite over hypotenuse is sine, so that's going to be the sine of 30 degrees is equal to opposite over hypotenuse, which is 34, I think that was. We're going to multiply. So we're going to take 34 times the sine of 30. Let me clear that up. 34 times 30 sine, press equals. So this is 17. So z is 17. So scratch that out and put 17 here. Okay, now that we have that, we can figure out this piece, and we got to figure out this piece, and then we got to add those up. We also need x. Okay, so we got a lot of things going on here. So let's do a first. Stay with me, okay? This is a. We know this is 17. We're looking for x. This is 45 degrees. So we have standing here, so this is opposite, this is hypotenuse, and this is adjacent. Okay, so let's keep moving. So to get x, which is the hypotenuse, you want to use O and H. So you're going to say the sine of 45 degrees is equal to opposite over hypotenuse. You're going to switch these two. So x is equal to 17 divided by the sine of 45. Use your calculator on that. That gives you x. We still have to find a. A is adjacent and opposite, so that's going to be the tangent. So it's going to be the tangent of 45 degrees is equal to opposite over adjacent. We're going to switch these two, so A is equal to 17 divided by the tangent of 45. Once you figure out that, you're going to have to add it to B. So let's go after B. Put a star by this. So B is going to be adjacent and hypotenuse. That's cosine. So put the cosine of 30 degrees is equal to adjacent over hypotenuse. Adjacent over hypotenuse, 34. So this is going to be 34 times the cosine of 30. Now, you want to add up the A and the B to get the whole thing, which is y. Okay, so you're going to add these two up. Let's just do that real quick since I'm already into it. So 17 divided by 45 tan, press equals. So one of them is 17, A, plus B is going to be equal to y. So this one is going to be 30, and then cosine, and then times 34. This one really requires a lot of work. So that's going to be 29 and some change. So you're going to add that up. So plus 17, and I'm going to get 46.4 is equal to y. All right, that was a doozy. You might want to save that one for last. All right, let's keep moving. This one right here is a work backwards. So you have a square garden, okay, and the area, so the area of a square, we've got another formula. This is a problem you need to know, is equal to 98 square meters. Okay, that's the area of the square. The formula for area of a square is side times side, S times S. Okay, so put S times S is S squared. So S squared equals 98, and then all you do is take the square root and you get your answer. So the square root of 98, shift, square root, I get 9.9. 9.9 is what the side is. Okay, watch. 9.9 times 9.9. It's going to be close because I rounded it. It's almost 9.8. Well, it is 9.8. All right, let's keep moving. All right, where am I at? Number 14. The area of a square, a piece of art is in the shape of an equilateral triangle. So number 14, draw an equilateral triangle. That means all the sides are sixes. Okay, and what you want to do is find the area. Area of a triangle is 1/2 the base times the height. The base is 6, so put a 6 right here. And the height is right here, so you're going to drop this down and you're going to split this triangle right here. You're going to split this triangle into 1/2 of 6 is 3. So put a 3 right here. Now, an equilateral triangle, they're all 60s. 60, 60, and 60, which equals 180. So what you want to do is get the height. So you could do a lot of things here. You could do opposite over hypotenuse, or you could do something with adjacent. Okay, so you can do a lot of things. I'm going to do opposite and hypotenuse. So the sine of 60 degrees is equal to opposite over hypotenuse. So the height is going to be 6 times the sine of 60 degrees. Let's just finish this up since I'm already into it. So press 60 degrees, work backwards, sine times 6 times 6, press equals, and then divide by 2. I get 15.6, and that's going to be square inches. Okay, these are tough, okay, but I'm going to give you tomorrow to spend some more time on it. All right, let's go to number 15. What's the ratio? This is an easy one. Here's P. Tangent is opposite over adjacent. So if I'm standing at P, opposite is here, and the adjacent is that. So that's 16 over 12, and then you got to reduce it by 4. So divide by 4. So it's going to be 4 over 3. So the ratio is 4 over 3. Now look at Q. If you're standing at Q, tangent is opposite over adjacent. So this one is 12 over 16. and then you want to divide by 4 and get 3 over 4. Okay? And those are your answers. And those are the easy ones. All right, let's keep moving. I'm almost done. Write the ratio for the sine of x. This is an easy one. You're standing at x. Sine is opposite over hypotenuse. So the opposite is the square root of 119 over the hypotenuse is 12. Okay? And that's your answer. The cosine is adjacent over hypotenuse, so that's 5 over 12. All right, we're getting close to the end. Stay with me. This one right here is straight up trig. So it looks like it's going to be opposite over adjacent. So it's going to be the tangent of 40 degrees is equal to opposite over adjacent. You're going to switch these and you're going to get your answer. So it's going to be 4 over the tangent of 40 degrees. This one right here, you're going to do two different triangles. Let me think about this a second. You're going to first do this triangle here. I'm just going to tell you how to do it. Okay. This is 42 degrees. This is 12. So you're going to find W first. Then you're going to take the great big triangle and you're going to use 27 degrees, okay, and 12, and you're going to find this whole thing here, which I'm going to call Z. Once you find Z, you're going to subtract W and you're going to get X. Okay? This one right here is trig. It's opposite over adjacent. That's tangent. So that's going to be the tangent of angle X equals opposite over adjacent. And then you're going to divide by the word tangent. So it's going to be the inverse function here. This is the first inverse function that I'm seeing. Okay, this is another inverse function. This is opposite over hypotenuse. So that's going to be the sine of angle X equals opposite over hypotenuse. You're going to divide by the word sine. So it's going to become the inverse function. And then you're going to be done. Use your calculator. All right, focus on the easy ones, and then remember to try the hard ones. All right, good luck on your test. Your test is Wednesday.